all the presenters that have been going on Thursday, Friday, tomorrow, that signed up for this rather busy schedule that we have put together. And so thank you. And a couple of them really stepped up the plane. One, particularly like Amir, for example, Dr. Montgomery wanted to do the coding thing an hour ago, and he wasn't able to do it like he thought. And I asked him, he was like, "Yeah, I'll take it." I was like, "Cool." So it's like, and last night I had someone around the patio, and they're like, "Oh, God, DroidCon's going awesome." And I was like, "Well, that's just because the builders are having DroidCon." I mean, it's the I can't tell you how much I appreciate everyone stepping up and doing stuff and staying on track of the schedule and just putting in the camaraderie that's going on here. It's fantastic. I mean, I just basically wrote a schedule, and everyone is just executing DroidCon. So thank you very much for that, because you guys are doing awesome, and that's why we like DroidCons. I love DroidCons, because we get together and do these things. So that's enough of that. But no, but great, thank you. It's a good time. What I wanted to talk about, a lot of you have been talking to me already, but I just wanted to do an open Q&A on it, so people that had questions that didn't get in front to look at it yet could go through how the system integrates. This is my son Andrew. He drove up today to help me, and so he's going to push buttons on the laptop, and we're going to scroll through. I'm just going to go through the sales start because the images are there, and should I pull this thing apart and show you how it goes together and answer questions. Because there's a lot that you can do. And I built it as a platform for builders to build onto. So what I wanted to do today is talk about how you do that, how you create your own stuff with it, and then share those, and then I'll put it in the STL file, and then other people can print it and try it out, and we can create all kinds of fun stuff with this. Okay, sound good? So what you're looking at is is my bot with the work core in the center of it, and I call it the work core dome system because I really as a warp cell, I was like, I'm going to get this thing. Where's warp cell come from? I haven't used it gaming since 1999, and I never stopped. But all my passwords are warp cell. Everyone's going to try it. Even my grinder. Anyway, so the work core dome system is the entire thing, and it's comprised of the plate, the PCB sets, the STLs, everything. Even the swap boards that are in the soldering room, which if you have not been to the soldering room and you want to make a couple swap boards and take them home, there's a bunch of them still back there with some terminals. What you build, you take with you. Don't be greedy, leave them for other people to solder too, but if you want to go get a couple of them, they're on the house, just take them home. But anyway, so that's the whole system, okay? But it starts with this thing. We'll scrub a little bit here. The base plate itself is acrylic. It's a high quality acrylic. It's machined by Philip Wise. Okay, so I'm not doing these in my basement. These are done at his shop in Texas, and we all know Philip's quality level when it comes to machining. I mean, we probably almost all of us have the skins possibly on our droids, and so he's doing this for me. And I designed it and sent it down to him, and he machined it out, and that's why it's so precise. And I had someone ask me if I'd release it as an STL, and the reason I have not is because it doesn't work printed. I tried printing it, all kinds of things, but it needs to be one of those parts that is actually machined for the magnets to seat properly and be the right depth and match up perfectly. The variables are in the things you're going to print anyway, and those can be a little forgiving, but the magnet pockets and the depth and all that need to be actually machined on it for it to work right. I tried. I had a few builders try to print it, and nothing, is it a 12.9 hole, or is it a 13.1 hole, or is it a 12.7 hole? Well, in this one it's a 12.9, and this one is a 13.1. What do you think? So it's like, machine was the way to go. So that's the foundation for the whole thing. Everything else you print at home, and you build yourself, and you knock it on. You just buy some magnets and screws, and it's good to go, okay? This is by itself just a dome plate. So if you are looking for a dome plate, and you don't know what you're going to do in the future, you can get this and use it and be just fine. And if you never use it, you got this really cool thing which you can pick an LED underneath it and it'll glow, and the kids will love it. Which is true, they love glowing things, right? Matt walks in a room and glows. They're like, it's the blonde guy. Because if you haven't seen his blonde, you have not seen the blonde. It is fantastic. So Anyway, yes, he deserves that. So anyway, so the base plate is the foundation for it. And there's an STL file in a link on AppsConnect that I keep updating it. So always check back and see, because if somebody comes up with an idea, I'll update the file with extras. But I really vet the designs as best I can, print them, try them, make sure they work before I put them in the file folder. So if it's in the file folder, it's going to work on it. No problem. And there are some really great ideas that come from builders. For example, this piece has, this is the Saber launcher. Right? So Saber launcher, you can print it. By the way, you can install that on any plate. You have to figure out how to do it, but you can. I mean, you can stick it on, you can put it on a Jedi plate or an Imperial plate or whatever you want to do to make sure you get it spaced right, or it's going to actually launch out. You can. So you can all have Saber launchers even if you don't have a plate. That's just the best way to do it. The plate aligns itself automatically and it will clear that shot. So anyway, that being said, when you print that thing, it's like, well, we're going to install it, but how do we install it? What do you want? Or you can magnetize or screw it. But what if you want to create something with it? Well, if you want to create something, I want to bring attention to these things. This is in the STL folder. This is a blank, I call it a warp cell. It's a blank warp cell. And it will lock onto the plate. Now, you print it out, and you can drill holes in this thing, cut into it, and install anything you want in it. The new design that you print out actually has the opening of the dome etched into the bottom of the cell. So when you're building in the cell, if you stay within that outline, it's coming out the top of that dome. So now, you basically have your dome layout on your bench in a small form. So you can build this thing like crazy, and just make sure you don't breach the sides, because the cells lock, they fit right around it, okay? So this is your building space, and do whatever you want with it on the inside. What you don't want to do is cross into the center of the droid, because if you're going to have the other goodies, you need room for the Saber launcher to swing into position to launch, and so that's the only caveat. So you want to try to build within this space if you're going to fully populate your plate. If you're not going to fully populate the plate, have that, man. This will do anything you want. It depends on how you want your droid to be. So the core system allows you to customize your dome animatronics coming out of it. So like right now, what you're looking at is a number of different things. We have the periscope. By the way, the IA periscope footprint was the foundation that I chose for all of the magnet placement. Because when I went to Celebration in 2017, I saw a lot of droids there that had periscopes and things coming out the top. And there were a lot of droids that weren't having periscopes coming out the top, and their builders were very frustrated. It's because the droids made the travel all the way to Orlando, and all these things were screwed down to the plates. And those of you who have got things coming out of your dome, you know there's just millimeters of clearance to get out that hole, right? And so they took all the potholes from the way down the floor. And when they got there, they were out of calibration. So I saw builders that were totally like dismantling the tops of your droids to get the periscopes to work and to get other things to work. And they were very frustrated. And I thought, well, what if these things were able to be transported on their own and self-aligned upon arrival? And that's where I got the idea of using the magnetic system. And also, if you got to work on something, you just peel it off the plate, put it in your workbench. Take it completely apart, you break a cell, print it on. It makes it really easy to modify. So that's how it came about. Because I knew that I was definitely going to have that problem of calibration. So I went ahead and created something that's self-aligned. So these are very important. I haven't seen a lot of them out there, so I wanted to bring it to attention to DroidCon, so that you can print these things and play around with them. People are asking, can you do a lifeform scan? Can you do a lifeform scan? I want to do a lifeform scan really bad, but I also want to see if someone else can do a lifeform scan better than I can.
That's just cheating, because they're hard.
What's that?
That's cheating, because they're hard.
I know.
Someone else do it.
That's why we need the group think. We need the group think. I'm calling on the builder intellect. Please, great builder intellect. Let's see if we can do a lifeform scanner that gives us 360 rotation control with alignment, with proper height. That can spin like crazy, like the periscope does, while the droid's moving in the opposite direction, and the dove's moving in the opposite direction, or making small children vomit as they watch it. That is the goal. That is the dream. So anyway, so these blank warp cells are for that, for building. And there's a couple versions. There's this version that has the sides, but But I've also got the blank plate that you can print on. If you don't need walls, you got this one. You just print it. And you can build onto it. It's very simple. You can put it in a Fusion. You can extrude things into it if you want to. There's all kinds of fun stuff like this. In fact, it just occurred to me that I may not have the Fusion file for these plates posted, so I will do that so that you can put it straight into Fusion and not have to mess with mesh. And then you can start pulling and pushing and creating and drawing and see what you can do, because I probably haven't given you all the tools to do that, because an STL import is terrible. Neil's like, yeah. So anyways, I'll do that when I get back. But these things and they work good for mechanical builders too. If you're not a Fusion person, drill it. Just mount stuff. Follow the diagram on the plate and you'll clear the top. So there's that. Going on to it, the layout that I've had a lot of questions like, where does the ring go? Does it ride or does it go underneath? When the thing is assembled, it does ride the dome ring itself. When you have the bridge boards in it, it forms a circle. It's drilled out for the dome bullets. I chose to do that with the holes because Phillips bullets are really cool. They help you get the dome on easy, and they are large enough that when this thing is actually wired into your dome, it stays in position, it doesn't move. The ring should free float this should free float on the dome ring itself. Because you want that to be able to move a little bit when you put the dome back on. Because that way it keeps you from torquing this thing. It just slides right down the dome bullets. So that was an idea. Any other ideas with this that builders have after seeing it today? Please send me some. I'm like, oh, okay. It's 2.54 pitch all around it. So if you've got other connectors you want to do that will fit it, go for it. Someone recommended JSTs, it was Brett. He was like, you're going to do JSTs on that. So that's a good idea. And you want to change the ring, you just change the connector. And just pop right in, 2.54 pitch JST. So there's that piece. And this is the outer rim. And then the other piece on this is actually the inner rim. And the inner rim is comprised of the PCBs that are going around the core. These purple PCBs, they're all blue now. These are the originals. You have them, they're just fine. I just changed the silk screen to everything back if you want. But these just do power, they don't do any signal. And you choose 2 voltages that go around the Droid. And if you need to pop another voltage into it, then yeah, you could always just run a wire on different voltages. But I figured 2 is probably all you really need. Usually like 12 volt and 5 volt to run inside of it. The power distribution board that's inside the core is this thing. It's a 4-layer PCB. 12 volts in, auxiliary volts in. The 12 volt goes through, the regulators, comes down the other side, and gets routed out. You have 3 voltages coming out of this thing. One for servos, one for Arduinos, and one 12 volt one. But really, it could be any voltage you want. There's nothing regulating on this board. Your regulators do that. So your auxiliary power could be anything you want. Your servo power could be anything you want. The 12 volt power could be 24 volt. You just have to, it's up to you to remember what you're using for it. That's why the silk screen is kind of like, is it 12 or 5 or 6? That's whatever you want on the inside of it. Because I wanted it to be universal to what you wanted to design, to go into it. Instead of reading my silk screen and going, oh, I gotta do this now. Whatever you want. Let's see here. Scroll up a little bit. I've had people ask, keep going, the slots. This is kind of, I had a lot of people ask me, Doug, why slots? Why slots in this? Well, it gives you 14 degrees of adjustment on the plate, because when you have a metal dome, you press the inner dome onto the ring, right? And usually you freeze the ring and you press it home. And if you did that when you built your dome, and you didn't have your Jedi plate or any other plate screwed on to the bottom of it so that you knew how you were pressing it, then your cross members may be off, so they're not like dead center in the middle of the pipe panel. You need the cross members to be dead center in the middle of the pipe panel. Or in this case on the plate, those big holes, the reason there are 6 giant holes in the center of it is because it allows you to put the IA lifter or any other lifter with a rotary mech anywhere on the plate, because the rotary encoder nests into that hole, by the way. So it nests, so it doesn't go under the plate, it nests into it. So that was the idea behind the big holes, to give you more flexibility. So the adjustment though is if you did get a bad press, that you put your inner dome on and you're off. The slot allows you to adjust this 14 degrees so that you can center it using the plate itself instead of having to pull the dome apart and repress it. And the dome bullet will lock the plate down when you put it on. And if you really want to get crazy, you can always take a little Dremel and just Dremel a little bit out of the plate, and then that way the dome bullet will go down into it. Just a little bit if you want to. I haven't had to do that. So just tighten it down with my hand. So that's why the slots are there. We use rolls. Keep going. So examples of the STLs are in the run. Keep going over. It's not very 16. Saber launcher, sabers, right there, something. Sabers are going to fly again. I've got a number of you have got your names on the Saber run already. That is active. If you are looking for a foam saber to launch out of your Saber launcher, please get your name on that list because we are making new molds as we speak. The lady who does it is Jamie. She's awesome. And yes, Jamie is a rookie builder and a friend of mine in Columbus, and she did the first round. We really, the price on it, I know when you look at it, you're like, man, this is like $7. Whatever. Well, they're handmade and they're hand painted, and it takes a week to do one. Okay? And she does them in batches, but still it's over a week-long process of going through and layering things. So, the reason we have not done another run since the original run is because we're trying to improve the mold process, and we're trying to find a foam that is not going to kill you, that is silver throughout. Because then what we can do, because right now when you get a saber, a naked saber is like white, and then you have to paint it in black, and then you got to put the silver on it, and then you got to put the gold on it, or the bronze, and you got to do the gold trigger, on the switch. And so we're looking for a solid silver thing that is the right texture, so that all you have to do is paint black rings on it, and you do this yourself. You use a Sharpie and just put black around it, bronze around it, and do the switch, and you're good to go. And as it rubs off, you can get the Sharpies back out and do it again. With it. So that's what we're looking for. And as soon as we get the foam figured out, we'll cast these things again. And that'll also be able to bring the price down because she won't be painting that much. Because I thought we can surely use Sharpies or our own paint if we want to and just touch it up if we need to. But being solid silver, I think, is a better idea. Is that what you guys think of that? So we're going to have those run again. And has anybody got the Saber launcher installed besides me? David has.
Yeah,
David?
before it exploded, but that's one.
Before it exploded.
You saw it in one
Pop shot off the top of it. Yeah, I've had some people ask me about the Saber launcher this week, about the printing orientation of the launcher. Mine, I've always gone straight up with it, and I designed it with some reinforced piece. But remember, when you 3D print something, it's like wood grain. So if you're going straight up, and you got layer, and David was telling me that he launched his, like the pop blew off the top, right? The top shot off it. So it was, so at some point during the print process, there must have been a bad layer in there, and that would cause that to happen. So I have some builders that have printed it at an angle with some supports because it gives you a better grain. Going this way. I had the builder did it on its side up there, that worked too. Probably on its side is the best, if you're having problems with the top exploding.
I'm thinking aluminum.
Aluminum, people have asked me for an aluminum. They're like, what can I do with aluminum? You do aluminum, the Saber launcher is no longer free to print. And it also adds weight to the droid. The Saber launcher is very, very lightweight, and it's a self-contained slingshot, is what it is. It's a slingshot in a tube. And I engineered it to snap together. So the lock collar snaps on the bottom, and it snaps into the frame, and the rubber bands you put on the launch plate, and so the servo turns the collar, you can even launch, and bam, shoots right at the top. Without the collar, it walks its way up the tube, as it's going, because it gets uneven release on the two rubber bands. And aluminum, you have to do like stronger rubber bands, and then you're getting into the idea that you got to use this really small micro servo to do it. And is the servo going to have enough torque? So that's why I haven't done it in metal, because the plastic is lightweight, it moves quickly, and the rubber bands don't have to be near as strong to get a decent launch. When I launch it. So, because this is the way it is now, and maybe John or maybe somebody said it. Anyway. So now, yes, Mike.
You're just using rubber bands?
Yeah.
Would surgical tubing work as well?
It might. I mean, I'm using just regular old blue rubber bands that I loop around the launch pad, and then it slots in the top. You know, because if you break one, I can real quick wrap one and stick it right on there when I go. Yeah, which I have done it to you. If you leave it loaded all day long, you lose about 4 feet of height because the rubber band is extended the whole time and it doesn't go back to its form as fast. If you saw the video of the clone trooper kid from the event that I did, he's dressed as a clone, not a clone trooper, he's dressed as a mobile clone, so he's a clone, and a child clone, and the thing is pretty high. That was shot in a church, and the ceiling was like 18 feet, and just got a good arc in slow motion, and I replaced the rubber bands and did that and shot. So that's what it'll do with new rubber bands. I thought about layering. You could layer 2 rubber bands per side if you wanted to. The question is, will the servo actually rotate the collar at that point? Because the unit being self-contained, all the force of the launch is on the tube. It's not on the rack. So the actuator will hold it in position, but the pressure on the launch pad is right here. And so when this thing is going up the thing, going up the thing, my wife would say, "What the hell is that?" I do that a lot. Why is the widget going in the ratchet thing? She's like, "What the?" So anyway, that's how this works. So it's getting this to turn is the problem. You know, what type of servo we're going to have to actually move it. And right now, a nice little cheap servo will twist this thing with no problem. So keeping the stress off the pad. So Mike, to answer your question, hey, you probably use anything you want if you got a servo strong enough to spin that collar. Yeah, because it's not going to affect the design of it. Because the collar doesn't have the button that holds it in, just as a button. And once you get the thing in position, it's not being pulled this way. It's just being pulled up into the tube. So if it'll turn this, yeah, go for it. Yeah.
You might not want it to launch too far either because you're going to be chasing it or someone's going to run off with it. So you might want to keep it, so it only goes so far to begin with.
Or on Thursday, you almost lose it in that.
Yeah.
That actually almost happened. It got to the top and it bounced off and I thought, thank you, John.
Doug,
Yeah.
one problem I had sourcing was the Clovis link elbow to the bottom servo. Is that the right name for it? I don't think you got that listed on part of this page today.
Oh, yeah.
I use it paper, but that's probably why it's
Well, it would probably stretch the paper, but that's true, yeah. It's called a clevis.
Clevis.
Yes, that's the name of it. You know, the servo guys know it, or servo guys and girls know what the clevis is.
Yeah.
And so the clevis is a very important thing. As it snaps together, it goes through the arm, the horn, the servo arm, and that's,
I don't know if you had it on there, but that's someone training that I had.
Actually, I did not have it on there. I just assumed it. Thank you. Because what happens when we assume? That's not what we mean. That's okay. So anyway, good point, Dave. Thank you. So yeah, but that thing just extends and goes up and you bend it, and you put it through the collar and it pulls it off. So yeah, great question. So anyway, the other design on this that I wanted to show you is how the whole thing goes together. Because I've had a lot of people ask me, I'm looking at time here, thank you. I've had people ask me, like, well, how does this whole thing work? And when you have it together? Well, the whole thing is based off the idea that your dome power is in a central location, not on the walls of the dome, and with 2 different things. So we're putting it in the core, the power cell. So when you have your slip ring in the middle, you can use any slip ring you want with it. Personally, I use a 4-line slip ring. Positive, negative, TXRX. That's what I'm using. And I'm not even using the TXRX right now because my system is wireless between the dome, the core, and the body. But you don't have to have that. I mean, you can have your dome and your core working off the same Arduino. It doesn't matter. Whatever you want to do. Like I said, I tried to make it universal. But the power and any signal coming from the body goes up to the slip ring and then goes into the power cell. And the power cell then takes that power, that main voltage that are running up, and splits it down to the other, using the 2 regulators, the 2 others. So that's where you get 3 voltages. The voltage going up, and the voltage coming to whatever you want for auxiliary and servo power, I recommend like 6 or 6.5 volts personally. I know it's a little higher. Heck, I could go with 750 and replace them all the time, really. But you do that and use like the blank speed, flipping and things like that. But it's up to you. For builders that are running 24 volts up and then breaking it down from there, you can do that too. You just put another regulator in the power cell, to do it. So everything is central to the power cell. In the cell, it fits a lot of stuff. I mean, I've got a Saber 2X12 in there with a kangaroo and an easy robot controller that's very bulky. and then I have 3 shelves, and I've got a bunch of PCBs and 2 regulators and 2 mag tags screwed to the front that I put the shelves on. The mag tags are specifically for the rotary lifter on there because the rotary lifter, if you really use it, you're going to maintain it. So you're going to be putting it on your bench a lot to do things. And it just makes it nice to pop 2 tags and just peel it right off. Because literally things snap onto the plate. So the premise is one central power supply and I designed it so you have space to put like a microcontroller in here too, just in case you want to have a controller just for the core plate, for the vertical stuff, that talks to the dome. And all of it comes through here, which is your magtech jumper, straight to the dome. And then that takes us to the outer rim PCB set that I just had up, that rides the center of the inside of the ring. It doesn't come out of your dome. Once it's in there, it's in there. Unless you want to take it out. But it's not going to go anywhere. It'll sit there. And the most important part about the outer rim is printing the gaskets. or a gasket type material. Had a lot of people saying, Doug, I don't have a printer big enough to print the 3 gaskets that go on the inside. That's fine. You don't even need to print it. Just get some decent vinyl and just cut it. Put your base plate on the vinyl and just go around it and then just cut sections on it. The idea is to get something non-conductive between the PCB and the dome ring if it's an aluminum dome ring. If you modify a 3D printed Droid to fit it, you're good to go. Because you're not going to have anything conductive there. But if you've got a metal ring, you definitely need a gasket underneath it so you don't short out. Because the outer rim channels power and signal on it. It was designed because builders had talked to me about coils being created inside our giant Faraday cages that we call middle R2D2s. And so when I did the ring, the 3rd bridge doesn't have power going through, it's just signal. So I wanted to make sure that we broke a coil so that we didn't have like this big giant electromagnetic thing there. The same thing with the inner rim set too, those do separate some of the coil.
I was just to say, have you considered formal coating the bottom of it so that you wouldn't have to put gas in it?
No, it's through hole. It's all through hole solder. So you could just, just brush on some stuff. And I've seen that before too. In fact, I was talking about it in the soldering room today. I can't remember who I was talking to about it. It was like brushing on. Mike, it was you. Yeah, we were talking about make the bridges that join the outer rims together, and put the cap on was important. And we were talking about, you could put clear VHP tape on there. Oh no! And then I was like, we can brush on some silicone on it too.
There's literally, electronic manufacturing, formal coating is the solution for that. It's a clear, not always clear, but it is an insulator like that.
But there's also liquid electrical tape that you can get like Home Depot that would probably do the trick.
Awesome! Toast it. I love it. I try to learn everything I can from the thing. I love it. Please post us ideas, and throw them right in the run, or message me and I'll put them in the FAQ questions on top and all that stuff. I love that because it's great. Yeah, you can paint it. How does it work if you have to desolder something and correct it once it's all out?
Your phone.
That's why I'm not doing it. That's why.
You saw it, right?
Yeah. We're back to VHP tape. Clear Gorilla VHP tape, everybody. That's what we're doing, right? Yeah, see it. I love that. Yeah, go ahead.
Because the other thing, I haven't had a chance to talk to you yet, but I know I did a dome ring back, many years ago, and I had more bridges than you do because you couldn't get quite
You
big.
had the 5 segments.
I had 6 segments.
6 segments?
Yeah.
Okay, and they were SMD, right?
Yeah, so
Okay.
through all, go through all,
Yeah.
if you have them.
Yeah.
But the other cool thing is I actually had like my micros on one of the bridges. So another thing you can look at.
I'm not smart enough to do that, but I like shields. So my thought process, because I had conversations with other builders who brought that up. Okay, what about ESP32? Why don't we? Well, they're upgrading those all the time, and I like shields because they're adaptable. And if you want to flip out your microcontroller, all you have to do is change the mount above dome panel 8 or whichever one that the big one, and you can stick it up. And that's why I didn't do it. And I'm really not smart enough to do that because I'm not. I mean, I don't have formal training, and obviously you have formal training.
No, very
A little bit, okay. Yeah. So I don't. So I'm very infantile to the point when I design things because I'm thinking, okay, well, and my friend Jeff is the same way. We were talking about making a board that would fit inside the power cell, like with an ESP32 on it that people can do other stuff with. And I was like, we should solder the board because you are forgetting the way that you do this is we want to have a socket so that we can actually plug it into a socket and then jumper it to the things we want. That way, if you need to change out your chip, you can do that.
Yeah.
And I was like, because the ESP32s, there's so many different ones, and they all have the same shape, the same appearance, there's tons of them. Some of them are different on the panels. So it's but that's why. Thank you. But that's why I didn't do it. But yeah, I never saw yours in person, but I heard about it.
Yeah, I've never brought it to. I've never brought it right there.
Well, it's revolutionary. I mean, really, for thing I think so, going around in a ring. So that's, and it was some of my inspiration to come up with a larger system like this doable because I can really create it.
The Fergal is definitely a good improvement.
Well, thanks. I thought it was like, I don't know if it works.
Well, Fergal's for like the components, SMT is better generally, right? But for the connectors, the Fergal being the worst.
Yeah, so that's why. That's like Drupal. So, no, this is awesome. Does anyone have, okay, well, hold on. Before we go to that, we covered the saver stuff. Can you go to the interim stuff? That. Okay. Going down. So this is the purple section. I was going through Osh Park, but I'm not doing that now. It's just got to be too expensive to run it and keep it going. But this is what's inside all the cells and the center and the power cells. So it's kind of a good breakdown of it. And this is what you get if you get it. It's got a little capacitor to help your voltage in the center for the servos because the voltage just is kicked back on the center plate. But this is what completes the whole thing. And I give you 5 just in case you don't have an IA lifter. You know, you can get a whole thing in there. And also, when I designed the outer rim, the servo positions, there are. Well, every conceivable panel can be animated on the dome. If you don't have a top HP and it's a panel, no problem. I've got a pin in there and you can put a servo on and install a dome panel there. If you don't have a lifter, no problem. You can put a dome panel in there, there's a servo pin for it. So there's DP1 through DP6 all the way around it on the top. And then all the way around the side, how many servos are there on a dome? I can't remember if you do all of them. 13. So there's 13 of them there, plus all of the different ones. So 13 plus 6. I got 19 servo routes in this, and they're all lined up relative to where you have the least amount of wire to run from the servo to the outer rim board. So it goes right down the wall, then right into it. So the rim, I have it on display over here. I'm putting the rim on top of the dome. And the reason I'm putting the rim on the dome for you to look at is so you can see how the rim is oriented based on all the panels, including the magic panel and everything else. And the Death Star plans thing is in there. I tried to think of everything that we could do. The trigger for the card reader in the front is in the front of the rim, and the trigger to flip panel 5 open and run the screens in the back, and there's a jumper that runs all that. Also on the outer rim piece, if you have to fill these Ryan's HPs he's got. I put jumpers in there because if you're using Ryan's HP controller to control your servos, you plug all of them in a central location in the front, and it goes to the back, and the jumper jumps them to where they need to be for your to plug right into it, including the light points. It's all there. Oops. So anyway, so that's another thing too. So that's what they're doing. But this is the inner system. So you don't need them to work together though. like the outer rim is separate from all the others. It can be separate. So if you've got your dome done, and you're about ready to do a big rewire, and you don't want to change out your plate, you don't want to do less, you don't have to. You can use the outer rims to clean up all your wiring and make it real nice on the inside. And you don't have to use those dome bullets. I mean, it's just bigger holes, but if you're not running dome bullets, that's okay. It's just going to be inside your rim. So you do what you like with it. So 335 covered a lot of stuff. I'm open to other questions. Because I want to make sure I get all those if anybody has them. Yes?
Are the rigs populated with components and solid yourself, or are they not?
You gotta build it. So, yeah, so like what you see is what you get with that. You gotta get a bunch of terminals, for those, but a lot of us already have those screw terminals anyway, and we order them. The outer rim, you get all the weird stuff. So like 90-degree stacks are coming with that. The headers and the sockets are coming with that, the 2x12s and the other stuff. And so there's a lot that comes with the outer rim. The only thing that doesn't really come with the outer rim are the rest of the pins you're gonna put in for the circles. But I do have a lot of stuff included with the rim that I just like, you know what? I don't want a builder to have to buy 50 of these or 100 of these to get this at a price that's reasonable. So, good question. What else? Yeah.
I'd say, early on, I jumped all over this as I was an amazing idea. Then when I looked at putting in my already complete Droid, I had a couple thoughts. Maybe it'll just some things from like periscope onto it. Sailors. But one of the things you were saying, one of the things you were saying was you got to treat that periscope like a delicate piece of equipment. You're not going to take it on the interstate through bottle and stuff like that. So you take it out and transport. One of the things I was trying to do was I wanted to carry it within the dome. So I took the dome off, we're transporting it upside down, and stay there. But now I'm thinking that it's got to be a delicate piece. I should be taking it out each and every time. You maintain it between so I'm starting to come around now that taking it out would be easy. Because I was thinking, how many times am I going to do maintenance on it versus it's in there when I need it to do an appearance.
Yeah. Yeah, well, that's the thing, man. You can do maintenance at the event too if you have screwdrivers with you.
And the other thing is,
Pull it right on.
you could put that dome plate into the dome if I wanted to.
You can. You can. You hit the stove right button on the right side. It's on there. Like maintenance guys like this, literally.
So your maintenance would be my.
This is it. And so, and guess what? Put a little steel plate on your workbench and clink. It's not going anywhere. So you have that. So this is the whole reason, because of the calibration thing. All the other stuff too. All that stuff. If your Droid travels on its side, that's bad. If you have stuff hanging off the front. And in this case, like I bought a Pelican case. I took the whole thing to Anaheim last year, and bought a big Pelican case for a rifle, and cut all the foam out to fit. You can actually get 6 cells in there, in the Pelican case. And I traveled with that on the airplane, and my big Pelican case with the dome. And I put a note in there. So TSA wouldn't go crazy. Tell them what it was, because they look at it. It looks like a hydrogen. Circles on the outside. But but traveling with the outside has been good for me because when I get somewhere, it'll function. But the maintenance thing is a huge piece. So anyway, put it back on. It literally finds itself. That's it. You get it visualized. Nope. There's so many. This thing, if it doesn't go up, hit the blue one. It's okay. I'm taking that out of your hours. He lives on his own.
The cardboard box behind the house.
All right, that's a good question. We got,
How hard is it to take the whole system off?
Oh, the whole system off.
It's like when I transport my Droid, I take my dome off and set that aside and just pick them up and it barely fits in the back of the car with just the body.
Mm-hmm.
So I have to take the dome off, take that off,
Mm-hmm.
and then when I get to where I'm going, put that back onto the dome.
I literally just put these aside, I peel them off, because they all plug into the center of the servos. So what I did is I grouped my servos into plugs and just tape them together actually with electrical tape. And just stick them in the thing, because everything plugs right into the center of it. So really, the only, the tricky part is just pulling it off and putting it back on again quickly. You know, I mean, you just want to make sure you don't cross the streams, which is why I originally had this with a, just you would put pins in it, and I switched to the GST because it was directional. Because I may have crossed the streams. So, yeah. I'm sure that answers your question. I mean, it's very fast, but I travel with it in a box.
So you just take the individual cells, you don't take the whole plate.
Right. Yeah, I just peel them right off. It takes me just a few minutes to pull everything off, and we get to where I'm going, and put them all back on, double check everything, and turn them on.
So coming from the typical Droid with body Arduino and dome Arduino, I would be thinking that the code for the dome stuff would be living in the dome. Where's the code for your Saber launcher living?
Well, this Droid is interesting because I've been using the, well, I started with the Easy Robot system, and they moved it into something called Symbian. And by that time, I had the Droid all running on it and doing what I wanted it to do from an animation perspective. I would never, personally, I would not use Symbian to drive a Droid. It's Wi-Fi, and it works okay, you know, for controlling a saber tooth. I never really got it to do that great. So I have a hybrid system using Symbian just for animations, and I use Shadow, which is going to actually go to RC soon for driving. But I'm looking to do like a really small RC handle because I just need forward, backward, and spin the dome because the animation system is a separate system. So my friend Jeff and I are working on something that's going to be kind of fun. Actually, I was talking to Kevin about remotes earlier, and the way Kevin's controlling his Droid is exactly what I was thinking about doing. Kevin's already done it, but I'm traveling like a different route as far as how you touch it and work with it because I want to go one-handed. But Kevin already has the software, his system that actually works. So again, I'm just shaking. But with the brains in this place is great. But it's like, but yeah, so it's that. So this is two operating systems running together. One just drives it, and the other one does the other.
Like I'm thinking if I take my dome turbo expander and that's going on the work cell board in this case.
You
Because
could.
I have a lot of crap around the dome.
Yeah. Well, you could, or if you're using your servo expander, you want to have this a single communications line out to the dome to tell it what to do. Depending where your Arduino or your Arduino or your ESP32 is. I mean, in here, I've got an ESP, well, let's forget about the Symbian thing, let's just call it ESP32. I've got that on the inner skin of the dome, Velcroed into position above the large dome panel and on the right side of the dome. And then that talks Wi-Fi to the core and gets power from the core. But it doesn't have to do that. Like I can have a serial line running across the mag tag from the core out to the skin, controlling the expander and things like that. So like I said, versatility. You can do a lot with it. You can I created the slip ring adapter board for this. Lynn Harper contacted me and he goes, hey, people asking for a slip ring. I haven't gone. I didn't want to do another one, so I just sent up to Glenn and I said, yeah, we made it compatible with the other slip rings, so that way you guys can use that, the ring you already got. And gals, sorry, it's not just guys here. So it's, yeah, so there's all kinds of possibilities.
I found my slip ring, which is an old one, it's too high.
Really tall?
You were saying I could drop it.
Yeah, and you can do, like I would just like put a spacer underneath it to bring it further down. We're gonna do them, you know, but it's, yeah. So that, like the trickiest part about the core is actually the clearing the saber launcher when it does the swing out to launch. You gotta have the slip ring has to be only so high, or else you'll just bump it, and you won't be able to get the, I think it's like a 17 degree. Everything is 18 degrees. So that will, to go out the side. So, great question. What else we got? Good. So, well, this is it. I want to thank all of you, first of all, for coming, because I've had a great time here, and I love talking with all of you, getting like great ideas. And if you are interested in like any part of the core system, the runs are ongoing. I do have more plates to be cut. Philip's got me on the schedule for another 35 on there. And it's been very warmly received, so I'm going to thank the builder community. Thank you all all for trying my stuff in the droids and using stuff in the droids. I really appreciate it. These feel real good. And yes, sir.
Well, Doug, since you got an extra minute, I actually have your Lifeform scanner. And I don't intend on selling them, so I will tell you guys what I've figured out, and you can take it and run with it. So, a car antenna.
Hold on. I'm going to give you this.
He doesn't
Because
want.
everybody wants to hear this one.
So, my Lifeform scanner will go up 3 feet and do 360 in both directions. Or I can stop it at 18 inches, or I can stop it at 8 inches. And so what I did finally figure out, a car antenna will not spin if you spin the bottom, because they have just a wimpy, all you need to do is go up and down. But a mechanic's expendable tool will. They've got enough friction in them to do it. So you basically replace the antenna with an expandable mechanics tool. And once you take that apart, you can figure out how to get all the sections. You got to reduce all the sections of a tool from 6 inches down to 4 inches, so that it's, and then you get a little Miata or something. There's a couple of really small, good, strong the antenna motors. Now here's where it gets bad. And this is where in order to get that really hard to push extendable antenna up now, you've got to take all the clutch stuff out of the motor. If it jams on the way up, like if you press it and the door's not open, it's going to make spaghetti and aluminum shaving out of everything. So you gotta have a few safety factors built in. Something to stop it besides, oh, I'm stuck, I can't go up, because no, it's not stopping. In order to get against, now, once it goes up and down, you just put a gear at the bottom of the shaft, and the whole shaft will turn if you turn the bottom of the servo. So you can do anything you want. It's up and it's down, and you can do anything you want with it. Then you got to take all that coil out of the antenna base too. I put it in copper tubing, and when I connected the machine to the top of the antenna, that has to be a swivel connector, and I put a rare earth magnet there. And now, in my copper tubing, 4 or 5 different places, I put reed switches that read the magnet, and so it knows, like I said, you can really literally stop it wherever. And it's going fast enough that you need to stop it at the top. You got to put the reed magnet 2 inches further before that. So you need to, if you do it, it can turn out really cool. You'll need to buy a few extra everything. Because as you're testing it, and that wasn't quite right, I know, because the pieces of it are over there, and the other pieces of it are over there, but it's really cool when you're done. But I'm not selling anybody one, because you'll be calling me going, hey, you know what, I'm not really happy with this. So, but it can be done, and it's really cool.
Thank you. All right. Thank you, Kevin. Now I know how to destroy my droid.
Yeah.
Challenge accepted, exactly. So, okay, well, there's an example of information sharing what we're doing. So, if you got an idea like that you want to put into the warp cells, please do. And please let them know. And if it works out, we'll put it in the STL file for the builders. You could put it in a build log or whatever. And but again, thank you all for giving me the time today and for all the great speakers. Yes, sir.
Just when you were explaining your setup with the Pelican case and archive it, are you saying that your Pelican case has your droid in this configuration right now, where it's the whole body and the top portion?
Oh.
Or you took the cockpit?
No, I travel, when I take the dome anywhere, I have a Pelican case that the dome will fit in, just the dome.
Just the right.
And then I have the rifle Pelican cases notched out to have the cells on their back in the case.
Okay.
Yeah, if I'm doing it, they travel that way.
Okay.
And so because when your animations fall out of calibration, it's really how they're mounted to the droid that has the problem. The internals are pretty like most of these animations are very simple. They're not going to go anywhere. Like rattling them to death and the trip wouldn't help anything. The Pelican case gives it some protection. That's only when I fly. If I'm driving from one venue to another, they literally go in a little cardboard box that sit at the base of my car, and I have a little foam thing and stick them in and wrap them in a couple layers of bubble wrap and stick them there. And then when they get run one, I pull out and stick them. Just for local stuff. That's flying with the Pelican. Yeah, I have the whole thing wouldn't actually the SUV I have would probably accommodate the Pelican case with the droid body. Just for room in the back. So, good question. Yeah. Anybody else? All right. Well, I'm going to wrap this 9 minutes to the next, and thank you all.